Question 1B, Part 2. In this case, the standard deviation needs to be changed. In the previous question, it was the mean that was changed. But this time, in this question, the mean is to stay the same. And we're going to find a new standard deviation. First, let's begin by writing up a normal distribution curve and put in the data that we already have, which is 1.1 kilograms for the mean. We know that currently 1% of the peas lie below 0.86736 kilograms. And the standard deviation, first standard deviation, is 0.1. What we need to do is reduce that standard deviation for the benefit of the customers. So what we will end up getting is a narrower normal distribution graph. The mean will remain the same, 1.1 kilograms. We will have a new standard deviation. We don't know what that is yet, but we will know that there will also be 1% below a specific weight, and that specific weight is now 1 kilograms. 1% of the packets of frozen peas lie below 1 kilogram. Now, because standard deviation is a measure of spread, we can look at the data that we're given and have a look at some other measure of spread and then compare that measure of spread with the standard deviation measure of spread. Okay, let's look at the measure of spread that we can see here so far. Well, we know that this is spread out here a certain distance from the mean. This 0.86736 is a distance from the mean. What is that distance from the mean? Let's work it out on the calculator. 1.1 minus 0.86736. We know that this distance from the mean as a measure of spread is 0.23264. Do we have any similar information over here? Well, over here we have the distance from the mean is 0.1. 1.1 minus 1 kilogram, 0.1. That is also a measure of spread. Obviously, that's less spread out than this over here. That 0.1, don't get that mixed up with the standard deviation. Just by chance, the old standard deviation is 0.1, and this is 0.1 over here too, but they're not connected. Usually they would be different values. Just by chance they end up being the same, which might be a little confusing, but just know that they are different things. Okay, so because the standard deviation is proportional to the measure of spread, we can write down the standard deviation and this measure of spread as a ratio. We'll write it out as standard deviation there, 0.1, which we get from here, divided by 0.23264, and we know that that is a ratio, or as a fraction, is going to be the same ratio or fraction as this over here. We know that because the standard deviation is proportional to any other measure of spread. This here is a measure of spread, so is this here. So we write down the new standard deviation of the sigma symbol as a ratio to the other measure of spread here. Note that, so this goes down there, that 0.1. This goes down there. Okay. Obviously we've got the old standard deviation here, which came from here, the new standard deviation, which we're trying to work out by changing the standard deviation here. Now all we need to do is rearrange this and find the answer. 0.1 over 0.23264 times 0.1 equals the new standard deviation. So we'll do that on our calculator. 0.1 divided by 0.23264 times 0.1 equals the new standard deviation is 0.0429825 decimal places. That is our final answer.